What is up, people of YouTube? In today's episode, we're going to make some epic smoke simulations for a rocket launch. As you can see, on my screen right now, these are some 240p renders for the animation, just for preview. And if my PC manages to render all the stuff by the time I release this video, you'll see some high definition stuff in just a second. But spoiler alert, my PC is really slow. And even in the tutorial, I'm a little scared that my PC might crash because there's OBS running and simulation stuff, but let's see what happens. Okay, now we have a fresh scene in Blender. The first thing I'm going to do is create a mock scene, for which I need a cylinder to act as a rocket. I saw on the internet that rockets usually start from like 50 meters or 70 meters. So I'm gonna go like 75 meters, and about 75 divided by 2, I'm going to put it here so it goes above. And the rocket is also not on the ground, it has to be a little bit above the ground, so I'm going to give it some room below, like a couple meters. I guess that's okay. So here's our mock scene with a rocket that's approximately, well, exactly 75 meters high. And let's go to the side scene and let's see what we are going to do. At the bottom of the rocket there's going to be a smoke emitter, and the emitter is going to emit smoke in this direction at a really high speed for the first couple seconds, and then the smoke should be able to grow in size and volume so it looks realistic and to scale. I saw a lot of references on YouTube for rocket launches, and there have been a lot of SpaceX launches these days. There's also a new movie called Rocketry, which has an amazing smoke simulations for the rocket launch. I loved it. I saw that in most cases, not in all cases, but in most cases, the smoke plume is almost as high as the rocket, and also that looks cooler. The original simulation that I made, the smoke was not as big as you saw in the previews. I exaggerated the scale by exactly 1.5 times, which gave it a cooler look. So what I'm going to do is erase all this, shift spacebar, and I'm going to go annotate eraser, trace all this stuff. The first thing that we need is an emitter. So let's go Shift A, an icosphere. Now I could start simulating smoke from this icosphere right now, but I need a little bit of variance in the emission of smoke. So what I'm going to do is go into modifier stacks. I'm going to add where did it go? Displace modifier. I'm going to add a texture. I'm going to go back into the texture to add a cloud texture. Let's see the size. I guess this works. Let's make it let's go back to the modifier stack. I'm going to increase the strength by just a little bit, and I'm going to choose object as a coordinate, and I'm going to add a null object in my scene. In the modifier stack, I'm going to select the null object as my object. Well, and what happens now is when I move the null object, the displacement map shifts and changes the displacement in our scene. I guess the strength is too high right now. Okay, that works great for me. So what I'm going to do is, in the beginning of my timeline, I'm going to add a keyframe by pressing I and location to move to the end of my timeline. To move it somewhere else in the scene, I'm going to press I again and add a location keyframe. What happens now is the keyframe will affect the displacement in our icosphere. Next thing that we need is to start simulating. So you could go into objects, quick effects, quick smoke, but I have this on a shortcut, so I'm going to press Q, quick effects, quick smoke. Now that bounding box is not at all the size we need it to be, so I'm going to select the bounding box. I'm going to increase the dimensions of the bounding box. Okay, so let's start emitting smoke. But the first thing that we notice is that the resolution of the domain is already bigger than the emitter, which is not really a good sign. So I'm going to increase it to 64 and hope that works for a preview right now. Okay, it does work for a preview right now. I'm going to go back to my emitter. On the fluid settings of our emitter, make sure the flow behavior is set to inflow rather than geometry, because we don't want just one spurt of smoke, we want a continuous stream of smoke emitting from this emitter. Let's bring down the flow source and enable the initial velocity. Now we need initial velocity in the y direction, positive y direction. So I'm going to increase it to like 800, and I'm choosing 800 because that is what I used. Now something's emitting at 800 meters per second from this emitter, the stream should be really thin. Now this is really thick. It might be because the resolution of our domain is still very low, which it is. And another reason might be that we could refresh our domain by increasing the resolution division and getting it back. What this does is it refreshes sort of the MantaFlow workspace, and we could try it again. It is okay, so it's not refreshing, which means it is the domain. So let's increase the domain resolution so that we can preview what's happening. Let's set it to 128. You see, it looks thin because we have reduced the increased the resolution, so now it can handle the smoke simulations better. But let's get it back to 64. My PC is throttling right now, and I don't want OBS to crash. Right now our smoke looks a little weird because it just comes into existence from nowhere, but we want to make it look like it's emitting from a certain point in our scene. For that, what we're going to do is animate the emission rate and flow rate of the smoke from our emitter. For that, what I'm going to do is go into the first frame and create a keyframe at our initial velocity at 800 meters per second. I'm going to move a couple frames forward and change it back to 300. That's what worked for me. Around 300, 400 was an ideal speed for the smoke to keep emitting from the emitter. Another thing that we're going to do is go back to the first frame and change the surface emission to 0, volume emission to 0. I'm going to create a keyframe to move forward a couple frames and change the surface emission to 7, let's say, and volume emission to 1. Now by animating the emission, what we did was at the first frame there is not going to be any smoke emitting out of our emitter, but as we move to a certain frame there's going to be a gradual increase in the amount of smoke increasing. But 20 frames is not long enough, I guess. I'm going to give it like 50 frames, I guess. Let's go to 120 resolution, and I'm going to enable adaptive domain. Now make sure when you are baking the simulation, the final simulation at a higher resolution, do not enable adaptive domain. For some reason it just glitches out and doesn't show anything later, or either cuts out certain parts of your simulation. Maybe that's just problem with my copy of Blender or whatever, or my PC is not good enough. Whatever the case, disabling adaptive domain solved my problem. I'll go back to the first frame and refresh the domain. I guess I did that. Let's play it. Let's go to my cycles renderer. Let's go to GPU compute and let's go to rendered view to scene world. Now in rendered view you can see, well, I don't know if you can see in the YouTube compression, but there are blocks in our smoke simulation. That's because the resolution of our domain is really too low. But we can increase the resolution later. Right now we need to work on our smoke. As you can see in the rendered view that our simulation looks sort of not good, kind of monotonous, not a lot of things going on in the scene right now. Now that's because when the simulation reaches a certain frame, for in my case 50th frame, the simulation does not have enough noise or variation in its emission properties. Okay, so let's fix that. Let's select the emitter, go to my graph editor, select the surface emission graph and control right click on certain points of our graph. So this will add enough variation in our scene, but we could add more by adding a force field, a wind force field. Let's bring it towards here. Let's increase the size. Let's rotate it in the x-axis by 270 degrees, and there we go. Okay, now we have added the force which is going to affect our smoke. Now I don't just want my smoke to fly away, so what I'm going to do is increase the flow a little bit and increase the strength a little bit as well. One important thing that I missed out is select my domain and border collision, go select the bottom so the smoke collides with the bottom. See, now we've got that noisy look where it's emitting, then not emitting, and there are these billows forming. These are going to help us later in the look of our smoke. When we add noise and we add vorticity, these variations will really help. Now in the rendered view, we see something, well, close to what we want, but not exactly. Now you see the smoke in the end is sort of dissipating away. Now this is a problem that I faced in this project, was that after the smoke reaches a certain point, certain distance in the domain, it starts spreading away, dispersing or something like that. It does not hold together to create that billowy look. Now this doesn't really happen in another fluid simulators like Phoenix or Houdini's fluid simulator, but it does happen in Tableau. I don't know why, maybe it's my mistake, but it does happen. To fix that, I found a workaround. I selected my emitter, I duplicated it, moved it ahead in the domain by like, how much is it, 50 meters? Well, let's say 50 meters. I increased the scale a little bit and moved it, well, that's a lot of scale. Let's go dial it back a little bit. And what I did was I went into its emission settings, back in the graph editor. Now what I did was I don't let it start to emit smoke in the beginning of the simulations for obvious reasons. Then there'll be two emitters, one here and one here. But what we need is for this emitter to start emitting when the smoke reaches this point in our scene. And that's like 30 frame, let's say 30 frame. I'm going to select the initial keyframes. I'm going to press G and move them ahead like 30 frames. And I'm going to leave rest of the stuff the same. It doesn't really matter. Now another thing that's going to be a problem is the initial velocity of this emitter, which is set to 800 if you remember when we set up this one. We don't want this to emit at 800 meters per second because that would be really high and we'll have another huge plume over here, which we don't want. We want this to emit at a speed at which this smoke would be, which is like 200 right now, because this is emitting at 300 and it's going to be lowered in speed to this point. So let's say around 200, 150. And I'm going to create more keyframes over here, some variation to create the better looking smoke. Save this project first. Let's go back to the first frame and let's play the simulation. PC is throttling right now. Everyone's on RTX. I'm still working on a GTX card, but it does the work right now. Okay, so you see these billows? Yes, this is really good. Okay, so that's the basic skeleton of our simulation. What I'm going to do now is making our smoke simulation better by dialing in some domain settings. Okay, so the first thing that we'll see in our domain settings is our resolution. Right now it's set to 120 and I'm going to leave it at 120 for now. For the time steps, I'm going to increase it to like 3. The more time steps you have, the better your simulation is. Simple math. Border collision, we only need bottom collision because, you know, only ground is reacting with our smoke. Now adaptive domain, I'm going to keep it on right now, but for the final bake at a high resolution, turn it off or don't, or face the consequences. I don't know, I just gave you a huge tip. Now comes a really important setting for your domain, vorticity. It's going to add some turbulent forces to add those noise in your smoke to give it that realistic look. And you will be very much tempted to just click on this button right here and increase it to 0.1. You might think, how could 0.1 really affect my scene? Let's see. I only simulated till 50 frames, but you can obviously see how it just fucked up my simulation. We don't really want that. So the best thing to do is go to my vorticity and add a 0 after the decimal. This is what's going to be best for your simulation. I'm going to refresh my domain again. Again, I simulated only for 50 frames, but it instantly looks much better than 0.1 vorticity. Now the other two settings called buoyancy, density and heat will make your smoke rise up faster or go down faster. I don't really want any of that for my scene. I want my smoke to just act normal. So I'm going to leave it the same. The next is dissolve settings, which I'm going to leave disabled because I don't really want my smoke to dissolve. Now comes another important setting for your simulation called noise. Right now you see our smoke simulation has vorticity, which gives it these billowy shapes, these huge blobs, but they're just huge blobs which will look like huge blobs in our smoke simulation without any detail. We need that detail which will make our smoke simulation look like this. These smaller details will really help sell your smoke simulation. Now again, noise settings are to be played with, but really carefully, like the vorticity settings. So I'm going to enable my noise. It's going to strain my GPU because, you know, GTX. And I'm going to set the leave the press factor to 2. You could increase the press factor if you have a better PC, but I'm going to leave it at 2. Now what a press factor does is it increases the resolution, but just for the noise. For example, your domain resolution is 64. You have this smoke simulation that looks good at 64, but you need to add details. But 64 is as small as the details go in your resolution. What MantaFlow does is gives it another layer of resolution for the noise, for that detail. If you increase the press factor to 2, it will create a 128 resolution domain for the noise. If you change it to 3, it will just multiply it by 3, whatever the math is. Now I'm going to reduce the strength to 0.1. That worked best for me in my case, and that's what I'm going to leave it at. I'm going to increase the scale to 5. Let's refresh my resolution division again. Let's go back to the first frame, play my simulation. Let's see, it's at 50th frame and it looks great to me. Trust me, it only looks weird because the resolution is too little. If I increase it, it will look much better. Now that's the simulation part of it. It is basically done. Let's figure out the caching part of it. Now in my domain settings, I'm going to go to cache. I'm going to set the folder that I need where I need it to cache. Now what replay type does is it bakes the simulation as you're playing it, but at a higher resolution or a low-end machine like mine, this doesn't really work that great. Next one is modular, which allows you to bake the initial smoke simulation first right here, and then you can add your noise and everything above that. You can bake it again. This allows you to, you know, have your basic skeleton first and then work on top of it, a little lighter on your machine. The next one is all. This is the one I use the most. I have my bake all and free all button in my quick effects, and this is what I use the most. I just bake it and I go away for a second, I come back and it's done. Well, the basic preview is done, not the final one obviously. But yeah, the format volumes, you'll select OpenVDB, which is the best optimized format for volumes in any software right now. So OpenVDB, and then you bake it. When you bake it, all of this data is saved into your drive in the folder you've selected, and you can use this VDB data to extract this simulation into any of your Blender project. Now for the initial downward thrust of smoke, follow the same steps you did before, but instead of having initial velocity in the y-axis, have it in the negative z-axis. Now it doesn't look that good right now, but if we select an emitter and from smoke, let's change it to fire plus smoke. Go back to the first frame. I'll reset my domain, and now it should look much better. Now after you have baked your simulation in your desired folder in OpenVDB formats, or after you have downloaded my VDB files from the link below, you can import them to your fresh scene to put them all together. Now in the new scene, I've created this ground plane. I'm going to go press Shift A, add a new volume and import OpenVDB, final plume, data, and these are the VDB files. I'm going to select all of them, press A and import OpenVDB. Let's go to the shader view, and here it is. Now if you look carefully towards your smoke, you'll notice that it looks good. I'm not saying it looks bad, but it's missing something. It's missing the noise that we added to our simulation. Why is that? Because the noise is saved in its separate folder, and it needs to be imported by the same method. Go into volume, import OpenVDB, go to the noise folder, select all of it and import OpenVDB. Now when you open your noise VDB files, you'll notice that you won't be able to see it, or in my case, as soon as I click on the shaded view, my Blender will crash. Now this happens because in the shader editor, Blender gave the wrong density attribute to our noise file. As you can see in our volume properties, the density attribute for our noise VDB is density_noise, but in the shader editor, it's set to density. You can fix that by changing it to density underscore noise. Okay, so this is the final scene that I rendered. That is a SpaceX rocket that I made. It's like 2 scale, 80 meters high or something like that. There's the ground plume in the center, and there's a thruster from the rocket. My PC is throttling, and there's that side billowy huge smoke simulation, which is scaled up by 1.5 times, which is not a lot, but when it's like 100 meters, 1.5 is 150 meters, which is a lot. But yeah, and I find it to be looking good. These trees are just there to sell scale, which they failed to do, but I still kept them. But anyways, I hope this video helped, and the files are available to download in the description. Thanks for watching. Like the video, I guess, and see you next time. Goodbye. Now the final OpenVDB files available for download in the description are baked at 400 resolution. That's the maximum my PC will allow me. Anything above that will crash my PC completely. It's not that good, but it's okay for an R&D project like this. If you want it, you can download it. Thank you.